At this point, we have completed the survey of questions. We have taken a look at the risk identification. The next step is to look at the predicted defects. The defect prediction comes directly from the risk identification. You can see there the percentile group is carried forward. That is what determines the predicted defect density in both operation and testing. You could think of the operational defect density as the defect density for the escapes, while the testing defect density is the density of the defects that are predicted to be found before operation and deployment. The defect densities are multiplied by effective size to get the operational defects in both testing and operation. There is a lower, a nominal, and an upper bound. This is a prediction. That's why we have the bounds. The size that is used for the calculation actually comes from the required inputs. And you can see here it comes from the estimated people years for this particular software. So the people years is multiplied by the defect density to get us the defects. We can also look at the trends. This is predicting the total volume of defects. We can also look at the trends over multiple program increments. With Agile development, the software is never done. There's always more releases. So you can see here, we could see a predicted fault profile over the course of several months. And you can see, because there's Agile development, it does take into account that there's a new program increment that will inject new defects. Let's look at the frequency. Let's go ahead and change this to 0.25 years, which would be quarterly releases. And we'll refresh our results. Now go to the prediction, which changing the frequency didn't actually have an effect on the predicted defect density, but what it does have an effect on is the overall profile of the predicted defects over the course of several program increments. You can see here this is forecasting out 8 years, which is a very long time. And if we're having program increments quarterly, that's why we see all this sawtooth curve here. The sawtooth is expected. Every time new features are added in a new program increment, you're going to inject new defects. This is perfectly normal. What we want to look out for here is that the releases aren't so close together that the number of defects actually starts to increase. We can see here it's leveling off over time, which is not bad. Okay, we can also export all the metrics as well as the tabular trend. And the other thing we can do here is we can estimate the portion of defects that can be fixed during testing and operation given our current staffing. So as a default example, we have 100 test hours available for fixing defects. That means we have staffing for 100 work hours. And if it takes an average of 16 hours to fix the defect in testing, for example, we can calculate it. At that rate, 7% of the defects would be fixed during testing that are found in testing. And we could do the same thing for operation. There's fewer defects predicted to be found in operation, which is why the percentage is higher. So we can do some basic trade-offs here between effort for fixing as well as the time to fix the defects. In our next segment, we'll see how the defect profiles are used to predict downtime and reliability.